Thanks everyone. My name is Hani Fahim. I'm the founder and CEO of VM Farms. VM Farms is a managed web ops company, and today I'm continuing a series of talks called Tales from the Ops Side. These tales are essentially ops war stories, detailing some of the experiences that we've come across in our daily operations. Today's talk is called Dr. Strangecron, or How I Learned to Stop Worrying and Love the lastcomm. So, like most of my tales, this one began on a quiet day, of course, in March of 2017, so earlier this year, when a customer submitted an urgent request. They were asking for some assistance in investigating a failed file transfer from the previous night. So this client had an agreement with a partner to deliver specific financial services, and part of this agreement involves transferring files via FTP on a daily basis. So pretty simple enough. This process was kicked off via cron, which is a job scheduler, and it was in the form of a Ruby script. Simple enough, and it would generate some data and upload it to the partner. Although on this particular night, the partner claimed that they never received the file. So this is a big problem, and it was very important because the implications of missing an upload window were huge financial penalties, and I'm talking very large, like tens of thousands of dollars per incident. And nothing on our client's end indicated a problem. And so, as you can imagine, everyone was keenly interested in figuring out what the problem was. So naturally, we had some questions to ask, right? Like, was logging enabled? And the answer is yes, it was. In fact, the client had their own logging configured inside their script, in a Ruby script, to capture any kind of errors. But the log files are empty. So that's kind of curious. Why were they empty? Was it working? The answer is yes, it was working. It was verified. We were able to test it, and you can show that it was writing out logs properly. So what about system logs? Was there anything on the system level that indicated a problem? In fact, there's a cron log. So every time cron runs a job, it logs an entry, and it's logged to tell you that it ran. However, it doesn't show you the status. It actually only tells you that the job fired. So at the very least, we know that it ran. Right? They were saying they never received the file, but we know that the script ran, so something was there. The obvious question is, okay, was it successful then? Did it actually succeed in execution? And this would prove to be the ultimate question, and there was no easy answer, of course, right? So it's time to search for some evidence over here. We decided to check maybe our network logs, right? Perhaps there was something obscure in there. Just a note, we don't track all network connections. That would be absolute suicide for performance. And we only log really crazy exceptions. And in this case, there was nothing. The logs are clean in this case. So we thought, all right, let's check our network graphs maybe. Maybe we can see if there was a different pattern that we can observe. But the data size that they're transferring is really small. I mean, it's on the order of a couple of kilobytes. So it's not going to register on any graphs, and definitely didn't in this case. So we thought, all right, let's call our upstream provider. Maybe they found something weird. Maybe they had some exception or some dropped packets or something that went wrong in that case. And the answer, of course, was no. So we're kind of out of questions to ask, which is tough. You really need to be able to ask more questions to be able to figure out what the solution was. So we had to dig a little bit deeper. We asked the client, what exactly does the script do? Let us know. And they're like, it's really, really simple. Just basically connects to a database, grabs some data, assembles it in a very specific format, and then connects via FTP and uploads. Just FYI, as an ops person, I take great offense to seeing any data transferred, especially secure data, over FTP. It's really insecure. It's an abomination. I'll just stop digressing here. So at least at this point, we can ask more questions, right? Like, it connects to the database. So was there anything on the database's end that would reveal what's going on? Was it overloaded? Did it run out of connections? Anything of that sort? Absolutely nothing. The logs were clean. Everything was running nominally. Okay, what about disk space? Did anything run out of disk space? The cron server, did the database server run out? No, there's plenty of room everywhere. How about any alerts of any kind? Did anything go wrong that particular night in the last 24 hours? Absolutely nothing. The logs, it was a quiet night, like I said. It was a very quiet night. Okay, so I mentioned that it created a file and then it uploaded it. So was the file still on the server? Because if it's there, maybe it shows that it didn't execute properly or was corrupted or something to that effect. And in fact, no, there wasn't anything there. And actually, due to the sensitivity of the data, they never actually write a file to disk. Everything's kept in memory, which is smart from a security perspective, FTP aside. But this also makes our investigation more difficult. So everywhere we were turning, we were hitting dead ends constantly. So what do you do at this stage? Well, we can state what we know. As far as we can tell, everything ran smoothly. All systems were nominal. There were no errors anywhere recorded, no alerts fired, at least unusual alerts. And the cron log says that it ran. So as far as we can tell, everything worked. It wasn't on our end. Of course, not so fast, right? That was not good enough for our client. At this point, finger pointing had ensued. Their partner insisted that they did not receive the file at all and that their systems were nominal. And so our client came back and was like, we really need some hard evidence here to figure out what's going on, because we're under time constraints and now penalties are being threatened. So up until this point, the penalties were only something in the contract, but now lawyers are starting to point at clauses and saying, listen, we're going to start exercising our rights. You better figure out what's going on. So back to that ultimate question, right? Was there some way to figure out if it was successful or not? We really needed to be able to answer this question. So we put on our forensics hats and tried to dig in a little bit deeper than that. So our next question was, all right, is the exit code recorded somewhere? So every process or program that runs on Linux in a shell, once it exits, it has an exit code. And typically exit code of 0 means that it's executed successfully. Any other number typically means that some error occurred. And what that number means is dependent on the program. However, it's universally accepted that exit code of 1 is a generic error. Something happened, right? So if we can find the exit code, we can put some pieces together. So we decided to take a look in the proc file system. And proc is actually this really neat virtual file system on Linux. It has a whole bunch of really neat information in there about running processes in the system. And in fact, a lot of Linux utilities use the proc file system to report information. It even allows you to live tune a server, which is pretty neat. And I suggested, it actually does a lot more than that, and I suggest you explore your proc file system, but probably not on production. So at this point, we decided, all right, let's take to the internet because we're out of ideas. Let's see what other people have to say about this particular system or issue that we encountered. And after some really deep digging, we found this old Stack Overflow post from 2011. And the question was, is there some way I can check which of my processes the kernel has killed? Now, this isn't exactly like our problem. We're pretty confident that the kernel didn't do any killing at this point. Usually when it does, it's really verbose and it would be splattered all over the logs. So, but at this point, like I said, all the logs are clean. But our soon-to-be best friend, Michael Ward, responded with, maybe process accounting could help here. And that's when a light bulb went off. Of course, process accounting, right? Process accounting is a method of recording and summarizing commands executed on Linux. This is from the man page. Modern Linux kernel is capable of keeping process accounting records of like what commands are run, who ran them, and how long, and much more. And that much more is the part that we're particularly interested in. The best part about it is we actually had it enabled, and we actually installed it 3 years ago to monitor deploys, so for something completely different. The process accounting is really powerful, and we use it to track whenever files are changed in the web directory to correlate that to deploys to help us, correlate events that we've noticed. And it was installed in this customer system, which is great. So did we have the file? And yes, we did. It's sitting right there, that glorious file. I love process accounting. And process accounting comes with several tools to parse its main log file, right? And it includes commands like sa, which summarizes information about previously executed commands. Okay, summaries, I'm not really looking for summaries. And then there's lastcomm, which prints out information about previously executed commands. Right? So that sounds more like what we're looking for. So when you run it, you immediately notice that it is incredibly verbose. It spews out a lot of information about all the various commands that have run. So it prints out the command, gives you various flags, it gives you, the user that ran, how long it ran for, but no exit code. No exit code to be found. So all right, let's see what else that lastcomm can do. And there's this nice little debug flag over there. So we thought, all right, maybe that can help us out in this case. Ran debug, and it spewed out a lot more information, a lot of confusing information. And of course, there's no headers to tell you what these numbers mean, because that would be helpful. I have no idea what I'm looking at here. Yeah, I have no idea what I'm looking at. There's just a bunch of numbers, right? So what does this all mean? So let's take a look at the man page. Maybe that will help us out. print verbose internal information. That's the most useful man page ever, right? Luckily, our good friends at HP, they years ago they cracked open the source code and figured out what it was printing. So it prints things like you'd expect, the user and group IDs, the various timing informations about the process, parent and child process IDs, but again, no exit code. And around this time is when we decided that we should probably learn how to read, because our friend Michael actually had more to say in that very same post. He had an update. Strangely, the P account file has information about the exit status. That's great, but neither lastcomm nor SA seem to print it. So as far as we can see, you'd have to write your own C program to access that information. And Michael lost some points at this point because I don't want to write C code. But again, learn how to read because there is even more. Update 2. Here is a version of lastcomm that prints out the exit code. The last two fields, S for signal, then E for exited, followed by the signal number or exit status. Only minimally tested. It doesn't matter, I'll take that, right? Of course, 404, page not found. What did you write, Michael? What did you write? We had to find out some way. How do you find out what he wrote, right? What did he write? We can contact him. His contact information was available online somewhere, and there was very limited time at this point, right? Because lawyers are pointing at clauses. You don't have a lot of time. Well, this is when we remembered that the internet always remembers everything, right? Yeah. There's the Wayback Machine. Yes. You guys know? Yes. Yeah, the Wayback Machine. If you guys don't know what that is, it's basically a digital archive of the internet. It takes snapshots of all the websites on the internet and archives it. It's run by this nonprofit called the Internet Archive. Go figure, right? Yes. All right, Wayback Machine to the rescue. There it was, our glorious patch that Michael had written, and this was from 2013. So it's snapshot a long time ago, but there it is. There's the patch. So let me ask you a question. What are the chances that the 6-year-old patch, when you run it, will just work, right? 0%. Not even close. It failed immediately right off the bat. It was not working. It turns out that this patch is made for a 6-year-old version of Debian and a 6-year-old version of lastcomm, and we're running Red Hat modern version. The two are not even close to being identical to each other. I mean, you take a look at his code, you take a look at the source code, no two lines are alike. It is very, very different.
What is Debian for those of us who don't know?
Debian is another version of Linux.
Okay.
So we're running Red Hat. Red Hat's a version of Linux. Debian's another version. They're quite different.
Old school distribution.
Yeah, old school.
Okay.
It's old school. Ubuntu is the kind of successor to Debian.
Okay.
But at least we knew what he was doing, right? We kind of figured out. We had the patch, so at least we can see what this guy was up to. And it's really simple. He was actually just printing out the exit code, right? He's using this structure over here, AC exit code, and he's just printing it out. So that sounds like something we can do. And he forced me into writing C code, right? But at least we knew what he was doing. So the very first thing is we have to figure out, have the definitions change, right? It's been 6 years. Everything has changed in the file. Maybe the definitions have changed. Luckily, they did not. In the header file, acct.h file, there it is. There's that AC exit code. It still exists. It's still there. That means it's probably still in our file. So next thing, how do we print this out? How do we figure out where to print it, how to print it, anything like that? Well, back to our lastcomm debug output, you'll notice the last two fields over there. That's the child and the parent process ID at the very end. It took a while to figure out where that was. So we just have to figure out where does this get printed in all the files. And after some sleuthing, we were able to figure out that it was in the aCCT RD file. And there it is, right? There's the PID and the PPID being printed out. So was it that simple? We just added a line over there that printed out the AC exit code. Was it that simple, right? So let's figure that out. So we created a patch file, we downloaded the source RPM, we modified it to add our patch, and it was time for the moment of truth, right? So we decided to compile it with RPM, and it did. Created an RPM file. That's great. At least it compiles. It doesn't tell you that it works, it just tells you that it compiles. So it was time to test. So you downloaded it, installed it on the customer system, parsed the log file, and then, fortunately, it did not work. I'm just joking, it did. There it is. There's our glorious exit code. It exited with 1. If you recall, exit of 1 means that it's a generic error. Something went wrong. This is the first time that we actually had some evidence to show that a problem had occurred. All this time, remember, all the logs, everything showed that it was nominal, but here it is, the exit code was 1. It actually did have an error. Here's some more interesting information. This is the execution time. And on first glance, you're like, wow, that's in seconds, that's ridiculous. That's 18 hours. Was it running for 18 hours? And of course, no, that's not in seconds, that's in centiseconds, because why wouldn't you log it in centiseconds? So that's more like 11 minutes. So that's a little bit more reasonable than 18 hours, right? Here's some more interesting information. This is the actual processing time. That's in seconds, of course. And processing time is the amount of time that a program is consuming a CPU. So in a given time period, if a program is basically slamming the CPU nonstop, doing a lot of computations, the processing time will be roughly equivalent to the execution time. That kind of makes sense. Only in this case, the processing was less than 5 minutes, but the entire script was running for 11 minutes. So that's kind of strange. What was it doing? Is this even normal? Is this a normal situation? Well, to answer that question, we decided to go to the previous night because now we know what the programs and how to read this output. And so the previous night's output showed that it executed a lot shorter. That it only ran for 48 seconds as opposed to 11 minutes. So that's very strange over there. And the processing time was only 31 seconds, so it's kind of close to the execution time. And of course, there's the exit code. The exit code of 0, which means everything went well. So we know that the previous night worked, and that is normal operating procedure for this program over here. And if you run it, if we ran it against previous nights before that, we can show that it was always about 50 seconds total execution time. So something was abnormal. What was it doing for 11 minutes? Just hanging around there doing nothing, but only processing for about 5 minutes. Was it waiting for something? Did it hit some sort of timeout? The moment we mentioned that, that seemed to be the magic word because it triggered our client's memory, and they said, yes, absolutely. We have, in our Ruby script, we have a timeout set over there. There's a 10-minute timeout, and 10 minutes is pretty close to 11 minutes, so that's pretty strong correlation there. So what does this mean? What is read timeout? So read timeout is the number of seconds to wait for one block to be read. So this is an outgoing connection. Their script is connecting to an outbound connection. It is sending data, and it's waiting for the other side to return back to it, to respond. And very likely, if the implementation is correct, it probably would ask several times, hey, what's going on? Are you there? Are you still around? And this means that for 10 minutes, it got nothing back, and it timed out. So this means we have our answer. Very likely, it means that it was not on our end. Now, it doesn't definitively mean it was the other end. It just means it wasn't our end. It's something in between. Very likely the other end, though.
Send the lawyers home.
Yeah, that's right. So to sum it up, the cron ran, grabbed some data, went to go upload, and then sat around for 10 minutes waiting for the other side to respond, saying, I have your file waiting for you over insecure FTP. And then it didn't work. The timeout triggered, and it exited with 1. The interesting point over here is the client's logging configuration that they had, it wasn't sufficient to capture this type of error. So they had it configured to capture standard types of error, but not this one in specific. So that's why it didn't show up in their logs. That doesn't matter. The client was really happy. They went back with their own contract and pointing with clauses, and they were very happy at this point. So some lessons to be taken from all of this. Process accounting is amazing. It's great for analysis. Turn it on. But be careful because on really busy systems, it can get very, very large. I've never seen it go over a few gigabytes of data, but again, heed the warning. Next thing is always log cron output and separate standard out and standard error. Had we logged the cron output over here, it probably would have saved us a lot of headache, but then it wouldn't have made for a good talk, right? And you can actually do this really simply, so this is an example. It doesn't have to be a Ruby script, but if you're running a script over there, that line over there, the one with the double greater than sign, that's how you separate the output into its own file. And this 2 with the double greater than sign, that's how you separate the errors. So when a script runs, it can write into 2 different streams. So if you want to see if an error occurred, you go to the one file, and then the log output gives you all the other data that it spits out. That's all I got. Thank you for listening. Any questions? Yes?
How long did this whole process take you?
This was all compressed in a day because they had no time. It was a 24-hour period that they had to come back, and if they didn't have an answer, smart lawyers can interpret that and say it's your fault.
Got it.
If we don't know whose fault it is, then it's your fault.
Okay.
Yes.
So is the process counting a kernel compile flag? How does it actually work?
It's a feature in the kernel, and you have to also run a process during runtime that collects all this data. So it's a combination of the two.
So would systemd handle that?
Systemd can handle that, yeah. Systemd just spawns it up. Most systems have. It's actually a pretty old feature. They say modern kernel, but modern is variable in this case. It's a process that you run. It's probably available on all your systems, so it's very easy to turn on. Very easy. It's really powerful. Any other questions? Yes?
Did you ever figure out what exactly happened?
Strong correlation. That's the only thing. They went back and they argued with the other side. I'm pretty confident that their side had some problems. Probably the server was down. They said everything was nominal, but they're using FTP. So how sophisticated can they be, right? I mean, why FTP? I don't trust them very much. The other side. Yes.
So did the client end up changing the way that they run cron jobs, or do you now kind of have a best practice for clients?
Yeah, that's a great question. Yeah, it's a fantastic question. We actually now, so our clients kind of have two options. They can, a lot of frameworks install their own crons as part of the package. I know that there's some Ruby packages when you install, they manage their own crons for you. So it's difficult to enforce something that is just get automatically written. But for the cron jobs that you really care about, we really strongly enforce it that we manage it. And when we manage it, we now wrap it actually in a Sentry handler, so it can record any kind of error into your like Sentry, which is basically like a exception aggregator. So any kind of errors that occur, you get this nice web interface that shows you all the stack trace and things like that. So now we just wrap every command that we run in cron, so it pipes it through Sentry. So it takes it to a whole other level than that log redirection. I strongly recommend everyone kind of take that route, especially with cron. There's a lot of stuff that can just go into the ether, and you don't know what's going on there.
Does that kind of procedure help you guys figure out correlations in your own systems? Like, for example, this client is having that problem and this client is having this problem,
Yes.
but client C isn't. So does running it in that sort of central help you guys help them?
You definitely do that, yes. You definitely do that, although some clients...
At least from a correlation perspective.
It's a really powerful tool for correlation. Any kind of data that you can get on a global scale is great for correlation. I can't tell you how many times clients break their cron, so it can get really noisy where you write some bad code and you don't realize that you deployed a bad cron, and it just keeps firing over and over and gives you errors over and over, and you think everything's running fine. So you come a month later and it's like, hey, how come my report doesn't work? So it does get very noisy sometimes, so we have to take special care about that. But it's really great for correlation. Any data is great for correlation.
Cool.
Yeah. Any other questions? Okay. Thank you very much.
Thank you.